4.8. So we are better be getting a new notebook. We are on page 431 or 432 actually. We're starting on 432. And I just went through, you'll notice on the assignment sheet I signed quite a few of these. And I'm just going to go through and do some of them. So these, what I'm doing are homework problems. I'm just not going to start with number 1 and work through it because I want to get to some of the harder ones, okay? So if you want to start your homework page, 4.8, we'll start it with problem number 6. That's where we're starting, okay? We're on problem number 6. Everything okay back there, Jay?
Yeah,
okay, did you get it figured out?
No.
Or which question is it? Which one is it? On the homework. All right, so quickly, let's go back and look at 27 on the homework. Better to do that now than to start with the word problems. It says, find, all right, you have to read this now, J.A. You have to be able to read it. It looks so hard, but it really isn't. I want you to start right here. What is that asking me to find? The angle whose sine is 1/2. So where do I look? 1 and 4, and it'll be in 1 because it's a positive number, and that is a special triangle. The angle whose sine is 1/2 is how big? 30. So this is a 30-degree angle. So now it says take 2 times that. That's 60. It says find the cosine of 60 degrees. Well, that's when I draw my triangle, 60 degrees. This is root 3, this is 1, this is 2. The cosine of that angle happens to be 1/2. Now, I do not want you to think there's anything special going on here because it happened to be 1/2. It's 1/2 because when I'm dealing with 30, 60, 90s, I don't have many options. Half the time it's 1/2 and half the time it's root 3 over 2. So it just happens they match up. So I don't think there's anything special going on there. The problem would not be doable without a calculator. It would not be doable if that were some random, 8/13 or something like that. But the fact that it's a special triangle means you can do it. Okay? All right, so now I'm doing problem number 6. So I'm back on page 432, and problem number 6. They do not draw a picture for me. The picture there goes to number 5. So number 6 says, a wire stretches from the top of a vertical pole to a point on the ground 16 feet from the base of the pole. So you have to be able to read and then draw a picture of what you're reading. Because I'm not going to draw pictures for you. They do some in here, but I'm not going to. You're going to be responsible for drawing all of your own diagrams. So we have a pole, we have a wire going from the top of the pole to a point 16 feet from the base of the pole. So this is 16. Do not put the 16 here. What would this be? What's this? That would be the length of the wire. So if it said a 16-foot wire, then that would be 16. All right, the wire makes an angle, of 62 degrees with the ground. Where's the ground?
Bottom right.
There we go. It makes an angle of 62 degrees with the ground. If it said the wire makes an angle of 62 degrees with the pole, then that would be 62, right? You have to pay attention. Find the height of the pole and the length of the wire. So 2 things. We're going to find the height of the pole and the length of the wire. One at a time. You cannot do both together, one at a time. So let's find the height of the pole first. Tangent. Very good, Brenton. Tangent of 62 is x over 16. So x equals 16 tangent 62. So I would go to my calculator and I would type in 16 tangent 62. And how tall is the pole?
30 feet.
30.09 feet.
Wait, do we need to be in radian or?
What do you think?
It's not degrees. We need to do degrees because 62.
Yeah, 62 is a degree measure. If your problem is in degrees, and most of these are, if your problem's in degrees, your calculator has to be in degrees. Okay?
So do you need the Pythagorean theorem to find the y?
Now, let's talk about that. Brenton says, should I do the Pythagorean theorem? Now, first of all, we have enough information to do the Pythagorean theorem, right?
Yeah.
I'm going to tell you I don't want you to use the Pythagorean theorem. What would be my logic? Why do I not want you doing that? Round off error. You've got round off error in here. We can do this problem without round off error. Now, if we ever have a situation, and we will, where we need to use the rounded off number, then we need to use it. That's it. We just have to. But if we don't have to, let's not. What would I do to find that side and not use the 30.09? Cosine. So cosine 62 equals 16 over y. And y equals 16 cosine 62. So I'm using my trigonometry and not my rounded off answer to do that. Make sense, everyone? Okay, what's next? Number 12, I picked number 12. All right, so let's see what's going on in number 12. To determine the height of the Louisiana-Pacific Tower, the tallest building in Conroe, Texas, see, you learn all kinds of things in math class. A surveyor stands at a point on the ground level with the base of the building. All right, so here's the ground, here's the building, here's our surveyor. He measures the point to be 125 feet from the building's base. And the angle of elevation to the top of the building to be 29 degrees 48 minutes. 29 degrees 48 minutes. That's the angle of elevation. Remember, the angle of elevation is, here I am, the surveyor, and I'm going to look up at the top of that building. I'm looking straight ahead. When I look up, I have to tilt my head, and that angle that I tilt my head through is the angle of elevation. Now, I picked this problem because what have I not taken into account?
It's not in degrees.
No, it is in degrees. Where's the surveyor's eye?
At the bottom.
On the ground, right? What have I not taken into account? His height. And I didn't take that into account because they didn't tell me how tall he was. So if they don't tell you how tall the guy is, you are to assume his eyeball is on the ground. It's not practical, but you don't know how tall he is. So we're just going to put it down right there on the ground. Sometimes they'll say a man 6 feet tall, and then your picture would look more like this, right? If we knew the man was 6 feet tall. But we don't. So we'll start with this. All right, what do I want to know? What's the question? Find the height of the building. We'll use tangent again. And of the functions, by the way, tangent is the most commonly used one. And it makes sense that it is because it's tied directly to slope. Tangent's y over x, slope is y over x. So it's used a lot more than the other. So 2948, tangent of 2948 equals x over 125. So x equals 125 tangent 2948. Now this requires us to remember how to use our calculators. We talked about this one day, but it's been like a month ago that we talked about this. Do you remember? We're going to put in 125 tangent. I got to make sure I'm in degrees. So 125 tangent Now, 29 degrees, so I put in 29, then you remember what you do? Second apps, that's your angle menu, and you pick degrees. And then 48, second apps, go down to minutes, and there we go. And the answer should be 71.59 feet. If you have forgotten how to get degrees, minutes, seconds on your calculator, or I should say how to enter them into your calculator, then you need to talk to a friend. You can figure it out. Huh? Seconds are alpha plus. Remember, that's the one that's in that very weird spot. Put it down there where.
Oh, and it's right next to
Yeah, you have to do alpha. You need your grades right. If you're doing seconds. This problem didn't involve seconds. Okay. All right, next. Let's see. What did I pick next? 15. What's going on with 15? Oh, this is a little bit harder one. Okay, so let's see what happens with number 15. The angle of elevation from an observer to the bottom edge of the Delaware River Drawbridge observation deck, located 200 feet from the observer, is 30 degrees. All right, so here's the bridge, and here's the observer. Out here's the observer, and the deck is located 200 feet from the observer. And the angle of elevation from the observer to the bottom edge, okay, so we've got like, here's the deck, and here's the bottom of the deck and the top of the deck, and the observer is looking at the bottom of the deck, and the angle of elevation is 30 degrees. Then he looks at the top of the deck, and it's 40 degrees. So this whole thing is 40 degrees. Now, I hope that makes sense to you. If I'm looking, let's say I'm looking at that maroon t-shirt there. If I look up to the bottom of the t-shirt and then I look up to the top of the t-shirt, aren't the angles different? Yeah, so that's why one of them's 30 and one of them's 40. And what do I want to know? What is the height of the deck? This right here is what I want. That guy right there.
Would it be like in between one?
What?
Less than or like less than greater than?
So, I don't know.
Or will there be an exact value?
There's going to be a number. We're going to be able to figure out how that is. We have exactly what we need to do that. Clara?
Would you do all of it? Like, figure out the height of the whole entire thing?
Yep.
And then figure out the height of just using the 30 degrees?
Exactly. Clara says we're going to make this two problems. We're going to forget this guy for a second, and we're going to look at just the smaller triangle. If we look at just the smaller triangle, can I find, I'll call it H, and H will be this right here. Can I find that? What would that look like in terms of finding H? What would I say?
30, tangent of 30.
Tangent of 30 equals H over 200.
Yeah.
So H is simply going to be 200 tan 30. Okay, so what does H turn out to be?
115.47.
115.47. Is that okay with everyone? All right. Now Clara said, find the whole thing. So find this, which I'll call C.
210.40.
So I'll say the tangent of 40, yes, Brenton, you're thinking ahead. Tangent of 40 equals C over 200. So C equals 200 tan 40. Does that make sense to everybody? So what's C? 167.82. Now our question was X. So now we just have to do what? 167.82 minus 115.47. And I don't have the answer in my book, so I'll take your word for it. What is it?
52.34.
52.34 feet. That's how tall it is. Now, there will come a day relatively soon where we will learn how to do that problem a different way. We will actually be able to work with this triangle right here. But right now we can't work with that triangle because all we have at our disposal is SOHCAHTOA. And SOHCAHTOA depends on a right angle. So even after I show you the other way to do the triangle, or do the problem, you can still do it this way if you want. You can always deal with both right triangles and subtract.
This one.
Yeah.
How is it 52? Yeah, 3/4 or 34 feet. If isn't it supposed to be taller than h? So like also.
No, we're looking at just this right here.
Oh.
The whole thing is 167. That's what we figured out. So no,
Just
this
the
would
height.
have to be smaller than this.
You just want the height of that.
The height of this, yeah.
Just that whole section.
This is, if you look at the picture they do, you can kind of see what it is. It's like a little thing on top of the bridge, a building or something on top of the bridge. All right, is that okay with everybody? All right, so that was a little bit harder. Let's see what else we've got. How about, what's 18? Oh no, 17. Let's do 17 first. 17, and then we'll do 18. One time. All right, so here we go, 17. The Coast Guard cutter Angelica travels at 30 knots. Okay, a knot, K-N-O-T, a knot, you've heard that word before. It is a nautical mile per hour. So when they say a ship is traveling at 30 knots, that's like saying it's going 30 miles an hour. The difference is nautical miles, miles measured over the ocean or over great distances, are bigger, a little bit bigger than regular land miles. Okay? And the reason that is because, well, because of the curvature of the earth. That's why it is. Anyway, that's why it is. Knots, miles per hour. Okay? So, we've got this guy going from his home port of Corpus Christi. So anytime I'm doing directions, I'm going to set up a compass point. Here's Corpus Christi right here. And he's traveling on a course of 95 degrees. We start up here. This is 0 and this is 90. So 95 degrees would be like this, right? This is 95 degrees. And he travels on that course for 2 hours. Now he was going 30 miles an hour for 2 hours, so this is 60. Knots is miles per hour, technically nautical miles per hour. So that's 60 nautical miles. Then he changes course. All right, so here I'm putting another compass point. Now he's here, and he's changing course. Now he's going to go on a course of 185. All right, so where's 185 going to be? Due south is 180, right? So here's 185. This is 185 degrees. And how long does he do that? For 2 hours. So that is also 60. Find the distance and the bearing from the Corpus Christi port to the boat. Okay, so this was Corpus Christi, remember that? Where we started. This is where we are now. So we want to know that distance and this direction.
Is the angle where he does the 185 instead of 90?
I don't know. We have to figure it out. I hope it is, but it doesn't have to be, and we'll certainly do problems where it's not. But let's see if we can figure out how to figure it out. Anybody have any thoughts on how to figure that out?
But you can't do that, you said.
No, you can do the, in this case, you could do the Pythagorean Theorem to find this distance. Absolutely, these aren't rounded off. So, yeah, so the distance, if you want to know the actual distance, I'll call it D. That would be the square root of 60 squared plus 60 squared, wouldn't it?
But can't we only do that if we have right angles?
Oh, yeah, which we do, but we don't know that yet.
See?
Thank you, Clara. Yeah, we do. I know that already, but you don't. So, okay, let's hang on to that for a second. Clara's point is, we better figure out if this is indeed a 90-degree angle. How can we figure out if it's a 90-degree angle? Michael?
The two other angles are 45 degrees because both the sides are the same.
Oh, wait a minute.
Wow. The size of
And
the
then it
triangle.
should be 60
Now,
degrees.
wait a minute. Can I have an isosceles triangle with angles other than 45 degrees?
Yeah. Yes.
Is that triangle possible? Yeah, so you're again, Michael, if that's a 90, these would both be 45s. But I don't know that's a 90 yet. I'm trying to figure that out. So let's kind of look at what's going on here. Do you see that you have parallel lines here when you drew your compass?
Yes.
How big is this little angle right here? Just that tiny one. That's a 5. So how big would this tiny little one be right here? 5. Because they are alternate interior. Now, this was 185, and this is 270. So this guy is 85 to finish off the 270 to get all the way around. So it is 90. Yes. Now, I knew that, but we didn't write it down and we hadn't established it. So Claire is exactly right. Don't be doing the Pythagorean Theorem until you are sure you have a 90-degree angle in that triangle. So now we're sure, Clara. So now we can find that distance if we want to. Michael, furthermore, you're right. Now we know these angles are both 45, if we need them. We really need the big purple one, but if, oh, wait a minute. Wait a minute. We need the big purple one.
What do you mean?
Oh. That's the direction of this new vector here.
You know.
So we know this was 95,
And then the other side's 180.
and we know that's 45, right?
45.
So what's the answer to the question? Okay, look.
140.
Yeah, it's 140 degrees. This ship is on a course of 140 degrees.
But it would be 145.
Yeah.
No, it's 95 to the black line, and then 45 to the red line. So all together would be 140. Now, what was this distance? Did you type that in yet?
84.85.
Okay, miles, nautical miles. All right, I want to talk about this for a minute. You guys are thinking to yourselves, oh, this is great. Mrs. Ford just loves babbling on about this, but this has no practical application, and you couldn't be more wrong. I want you to think about something for a second. This captain takes off. We know exactly what course he's on. We know exactly how fast he's going. Those are both very measurable things. Then he switches course and he sails to a different island or to someplace. He's going someplace else. We know that information. He's out here in the middle of the ocean now on the way to this island, and he had his engine stop and he starts sinking. So he SOS's, right? Somebody's got to leave port and come rescue him. How do they know where to find him? Well, they can use trigonometry to find him. Now, in this day and age, it's much more sophisticated than that. But back in the old days, every airplane had a guy on it called a navigator. And what was the navigator doing? That exact kind of stuff. That's exactly right. That is exactly right. So, if you want to rescue these people, you tell that guy you got to fly this many miles on that course right there, and you will find those people. All right, we will continue this tomorrow. Maggie, can you turn me off?